Architecture, and what I really want to try to achieve here is to make Mars seem possible, make it seem as though it's something that we can do in our lifetimes, and that you can go. And is there really a way that anyone can go if they wanted to? I think that's really the important thing. So.
Okay, thank you. Thank you very much, and I look forward to talking about the SpaceX Mars architecture. And what I really want to kind of achieve here is to make Mars seem possible. Make it seem as though it's something that you can do in your lifetime. And is there really a way that anybody could go? I think that's really the important thing. So I mean, first of all, why go anywhere, right? I think there are two really fundamental paths. History is going to bifurcate along two directions. One path is we stay on Earth forever, and then there will be some eventual extinction event. Now, I don't have an immediate doomsday prophecy, but there's eventually, history suggests, there will be some doomsday event. What the alternative is to become a spacefaring civilization and a multi-planet species, which I hope you would agree, that's the right way to go. Yes? That's what we want. Yeah?
Yeah.
So how do we figure out how to take you to Mars and can create a self-sustaining city? A city that's not really just an outpost, but could become a planet in its own right. And for us, thus, we could become a truly multi-planet species. But you know, sometimes people wonder, well, what about other places in our solar system? Why Mars? Well, just to sort of put things into perspective for you, this is an actual scale of the solar system. So we're currently in the third rock from the left. That's Earth. Yeah, exactly. And our goal is to go to the fourth rock from the left. That's Mars. Okay, but this gives you a sense for the real scale of the solar system, like how big the sun is, of Jupiter, Neptune, Saturn, Uranus. And then the little guy on the right, that's Pluto and friends. So this helps see it. I mean, not quite to scale, but it does give you a better sense for where things are. So our options, if we want to provoke becoming a multi-planet species within our solar system, are unlimited. I mean, we have in terms of nearby options, we've got Venus. But Venus is a high pressure, super high pressure, hot acid bath, so it'd be kind of difficult to make things work on Venus. It's not at all like the goddess. This is in no way similar to the actual goddess, so that would be a tricky one. Mercury, way too close to the sun. We could potentially go to one of the moons of Jupiter or Saturn, but those are quite far out, a lot farther from the sun. Much harder to get to. So it really only leaves us with one option if we want to become multiplanetary, and that's Mars. We could conceivably go to our moon. I have nothing against going to the moon, but I think it's challenging to become multiplanetary on the moon, because it's much smaller than being a planet. It doesn't have an atmosphere, it's got a 28-day day. Not as resource rich as Mars. And in general, Mars is far better suited to ultimately scale up to become a self-sustaining civilization. Just to give you some comparison between the two planets, they're actually remarkably close in a lot of ways. In fact, we now believe that early Mars was a lot like Earth. And in fact, if we could warm Mars up, we would once again have a thick, thick atmosphere and liquid oceans. So, but where things are now, Mars is about a half again as far from the sun as Earth, so still decent sunlight. It is a little cold, but we can warm it up. Has a very helpful atmosphere, where in the case of Mars being primarily CO2, Western nitrogen, argon, a few other trace elements, means that we can grow plants on Mars just by compressing the atmosphere. And it has nitrogen too, also very helpful for growing plants. It'd be quite fun to be on Mars because you have gravity, which is about 37% that of Earth. So you can lift heavy things, like bound around, like have a lot of fun. The day is remarkably close to that of Earth. Currently, we have 7 billion people on Earth and 0 on Mars. The issue that we have today is that if you look at a Venn diagram, there's no intersection of sets of people who want to go and can afford to go. In fact, right now, you cannot go to Mars for infinite money. Using traditional methods, taking an Apollo-style approach, an optimistic cost number would be about $10 billion per person. So, the Apollo program, current cost estimates are somewhere between $100 billion to $200 billion in current year dollars. And we sent 12 people to the surface of the moon. Wait, which was an incredible thing. Probably one of the greatest achievements of humanity, but that is a really steep price to pay for a ticket. I mean, that's why these circles only barely just touch. So you can't create a self-sustaining civilization if the ticket price is $10 billion. What we need is to move these circles closer together. And if we could cut the cost of moving to Mars to be roughly the equivalent of a house price in the US, which is currently around $200,000, then I think the probability of establishing a self-sustaining civilization is very high. I think it would almost certainly occur. Not everyone would want to go. In fact, I think a relatively small number of people from Earth would want to go, but enough would want to go. And who could afford the ticket? Then it would happen. I feel like looking at sponsorship, I think it gets to the point where almost anyone, if this was their goal and they saved up, they could ultimately save up enough money to buy a ticket and move to Mars. And Mars would have a labor shortage for a long time, so jobs would not be in short supply. So, okay. It is a bit tricky because we have to figure out how to improve the cost of trips to Mars by 5 million%. So that's not easy. And that sounds virtually impossible, but I think there are ways to do it. give you a sense of size, it's quite big. And the funny thing is that I think in the long term, the ships will be even bigger than this. So this gives you a sense of vehicles, by performance, sort of current and historic. I don't know if you can actually read that, but in expendable mode, the vehicle that we're proposing would do about 550 tons and about 300 tons in reusable mode. That compares to Saturn V's max capability of 135 tons. The white bar shows the performance of the vehicle, like in other words, the payload to orbit of the vehicle. So it's the first time a rocket's sort of performance bar will actually exceed the physical size of the rocket. This gives you a more direct sort of comparison, okay? If this is, the thrust-off level is quite enormous. We're talking about lift-off thrust of 13,000 tons. It'll be quite tectonic when it takes off. We decided to start off the development with what we think of are probably the two most difficult elements of the design, and one is the Raptor engine. And this is going to be at the highest chamber pressure engine of any kind we've ever built, and probably the highest thrust to weight. It's a full flow stage combustion engine. Maximizes the theoretical capacity that you can get out of a given source fuel and oxidizer. Okay? We subcool the oxygen and methane to densify it. So, compared to when propellants are used in most rockets, in our case, we actually load the propellants in close to their freezing point. And that can result in a density improvement of up to around 10 to 12%, which makes an enormous difference in the actual results of the rocket. Right? It gets rid of any cavitation risk for the turbo pumps. And it makes it very easy to feed a high-pressure turbo pump if you have a very cold propellant. Really, one of the keys here, though, is the vacuum version of Raptor having a 382-second ISP. Woo! This is really quite critical to the whole Mars mission, and we're confident that we can get to that number, or at least within a few seconds of that number, ultimately maybe exceeding it slightly. Ooh, the rocket booster. So in many ways, this is really a scaled-up version of the Falcon 9 booster, right? You can see a lot of similarities, such as the grid fins, obviously clustering, a lot of engines at the base. And really, one of the big differences is that we use the primary structure as an advanced form of carbon fiber, as opposed to aluminum lithium. And we get rid of the helium and the nitrogen. Oh, yeah. So this uses 42 Raptor engines, which is a lot of engines, right? But, we got a lot of experience with engines. We got 9 on Falcon 9, and with Falcon Heavy, which should launch early next year, we got 27 engines at the base, okay? So we got pretty good experience with a large number of engines. It also gives redundancy, so that if some of the engines fail, you can continue the trip and be fine. This chart's a little difficult to interpret at first, but we decided to put it up there for people who want to watch the video afterwards, sort of take a closer look, analyze some of the numbers. The column on the left, that's what's most relevant to you, and that gives you trip time. So, depending upon which Earth-Mars rendezvous you're aiming for, at 6 kilometers per second, departure velocity can be as low as 80 days. And then over time, I think we would obviously improve that, and in the future you might see trips as low as 30 days. So it's fairly manageable. Considering the trips people used to do in the old days, they'd routinely take sailing voyages that were like 6 months or more. Oh. So, to give you a sense of what it would feel like to actually be in this spaceship, in order to make it appealing and increase the portion of the Venn diagram where people actually want to go, it's got to be fun and exciting, and it can't feel cramped or boring. So the crew compartment is set up so that you can do zero-G games. You can float around. There'll be like movies, lecture halls, cabins, a restaurant, okay? It'll be like really fun to go. It's the fun frontier. You're gonna have a great time.
Hi, Ellen. We're here for you. It's very nice to meet you. My name is Aldo. And 3 weeks ago, I was at Burning Man in the Nevada desert. And it felt like I was in Mars. It was a dusty storm, and it was really cold at night, and there was no water. But there was one problem at Burning Man. With a population of only 75,000, there was a lot of shit. And there was no water to take it into the rivers, which is kind of what we do today in our current sanitation system. So I was like, is this what Mars is going to be like? Just a dusty, waterless shitstorm?
Hi, everyone. Lauren Grush from The Verge. The Mars architecture is supposed to serve as a backup plan for humanity, but you didn't touch much on how you will keep humans safe on the way over there from either deep space radiation or how they will live on the planet. Can you give us some insight into the life support systems, habitats, stuff like that?
Hi, Elon. My name is Zach. I'm a space enthusiast and a local idiot for Rooster Teeth. And I was just wondering, can you talk a little bit about the future of humans in space? And are you going to go to Mars? Because I would hate to put in all this work and then not go.
I think the first journeys to Mars are going to be really very dangerous. The risk of fatality will be high. There's just no way around that. So I would not suggest sending children. It would be basically, are you prepared to die? That's okay. Then you know you're a candidate for going. But really, this is less about who goes there first. Right? A thing that really matters is making a self-sustaining civilization on Mars as fast as possible. This is different from Apollo. This is about minimizing existential risk and having a tremendous sense of adventure. I think a thing that Mars really represents, there's the whole life insurance and protecting life and ensuring the light of consciousness is not extinguished, which I think is pretty important, backing up the biosphere. And to be clear, this is not about everyone moving to Mars. It's about becoming multi-planetary. I think Earth will be a good place for a long time. It's just the probable lifespan of human civilization is much greater for a multi-planet species. Now that's the defensive argument. The argument I find most compelling is that it would be a tremendous adventure. I think it would be one of the most inspiring things that I can possibly imagine. And life has got to be more than just solving problems every day. You need to wake up and be inspired and excited about the future and want to live. Thank you.